Let's check how to solve this problem from SBQ1. The first step is we'll write the table. Okay, so we get the mass of water, mass of ice, the temperature initial for water is 25 degrees Celsius and temperature initial for ice is 0 degrees Celsius. Final temperature, we have no clue. Remember, it is a water and ice problem, so we need to check whether ice will melt completely or not. Okay, so ice needs to melt first. First we identify hot and cold object. Ice needs to melt, so we'll first calculate how much energy ice needs to melt, so that you can calculate by applying Q equal to ml. We get it as 33,300 joules. This energy needs to be provided by water to melt all the ice. Remember, all the ice. If all the ice is not melting, that means final temperature will remain 0 degrees Celsius. This is the key point. If all the ice is not melting, that means final temperature will remain 0 degrees Celsius. Let's check how much heat water can provide. Its temperature will fall from 25 to 0 degrees Celsius. We apply Q equal to mc delta T, substitute the values, and we get it as 31,395 joules. This energy is less than the energy required by the ice. That means ice is not going to melt. All the ice is not going to melt. That means some of the ice will melt, some of the ice will not melt. So it will be ice-water mixture, and hence the final temperature has to be 0 degrees Celsius. So remember, in ice-water problems, wherever ice is involved, you need to check whether ice will completely melt or not. If it does not melt completely, the final temperature will be 0 degrees Celsius. Now this question was about change in state, because it says temperature does not increase during boiling. In boiling you have change in state. The correct option was B. Let's see how to solve this. Remember, temperature is measure of average kinetic energy. Recall this, we did this in class. Now if temperature does not change, as in the case of boiling or melting or condensation, that means kinetic energy cannot change. During change of state, atoms or molecules move their positions. That means they move apart or they move closer. And position is related to which kind of energy? Definitely not kinetic energy. Changing position is related to potential energy. That means when there is change in state, potential energy will change. The next question, again, this question is asking you maximum amount of ice which can melt. So first step is to make the table. Now, because it's asking you directly maximum amount of ice that can melt, it implies that all the ice is not going to melt. That means final temperature will be 0 degrees Celsius. That's how we get the final temperature. The heat provided by copper, mc delta T, that's what the equation, and we'll calculate it. We'll find that it is minus 400,000 joules. Applying calorimetry, Q hot, negative Q hot equal to Q cold, identifying hot object as copper and cold object as ice. Substituting, mass of ice is not known, we calculate and get the answer, 1.14 kg. Next question is again about water and ice. So it's asking you what is the final temperature of the mixture. So remember, if ice is involved, we have to check whether the ice will melt completely or not. All the ice will melt or not. If not, the final temperature will remain 0 degrees Celsius, because if all the ice is not melting, it's an ice and water mixture. Okay, so we make the table. Again, as in the previous question, we said there is no clue, we don't know what's the final temperature here. We find the heat needed to melt the ice completely. Now here ice is at negative 20 degrees Celsius. Remember, it's not at 0 degrees Celsius, so we have to bring it to 0 degrees Celsius and then melt it. So the heat required will have two parts, mc delta T and ml. We apply the formula, apply the numbers, and we get the answer for the heat needed to melt 5 gram of ice is 1874 joules. This energy should be provided by water. Let's check whether water can provide this energy or not. Now for calculating the heat provided by water, water is at 30 degrees Celsius, we have to bring it to 0. There's only change in temperature, so mc delta T. Apply the formula, we get the answer as 627.9 joules. That means we can say heat provided by water is less than heat which is required to melt all the ice. That means again it's an ice water mixture, so the final temperature will be 0 degrees Celsius. Okay, next question we have about calculating the ratio y over x. So we first make the table for ice and steam. Okay, it's clear from the question what is the initial temperature, what is the final temperature. Apply the calorimetry equation. Now here if you see Q hot, it's steam which is condensing from a gaseous state to liquid state, so it is latent heat of condensation. And remember in the table we had latent heat of vaporization, so we have to just take the same value but make it negative. Now ice is at 0 degrees Celsius, it has to come to water at 0 degrees Celsius, then water's temperature has to increase to 100 degrees Celsius. So on the right hand side we have two expressions. We substitute the values and replace the masses by x and y. Again check this. Negative. Why it's negative? Because in the table we have latent heat of vaporization. Now it is mathematical problem. We take y common, rearrange the equation to get y over x. We get the answer as 3.